Good morning, grade 11s. It's Thursday, May the 7th, and we are going to be moving on to the next section of our sound unit, our waves unit, where we've moved into sound, and now we're going to move into a separate section within sound. And so yesterday you were simply working on an assignment. I got one question emailed to me that I answered by email, and I didn't get any other questions, so I have nothing to go over in today's video. But again, if you have questions, make sure you're emailing them to me. Before we get into today's lesson, I just want to share with you a verse of the day from Psalm 130, verse 5, where it says, "I wait for the Lord, my whole being waits, and in His word I put my trust," or put my hope. And so it's again just a good reminder that our hope and our trust needs to be in His word, not in the things of this world, but put your hope in His word. All right, so today we're going to start looking at the physics of music. Now, I am shockingly not a musician in any way, shape, or form. And so while I know the physics of it and how it all works to make it sound good is something that I am not always aware of. So today we're going to look at vibrating strings. And so any stringed instrument, guitar, violin, bass, etc., would follow these fundamental rules in terms of creating the sound. And so we're going to quickly look at some of the important factors that go into creating particular sounds, particular frequencies. All right, and so if we have a stringed instrument, and I scoured the school earlier today looking for a guitar or a violin or something that was a stringed instrument, and I could not find one here. So maybe for tomorrow's lesson I will bring in a guitar and be able to show you some of this stuff in practice rather than just talking about it in theory. But the theory remains the same regardless. And so when we look at the frequency, now remember that frequency is equal to the pitch, and the pitch is the note that you're going to hear, right? It's the frequency that determines the note you are hearing. And so when we're talking about vibrating strings on an instrument, there are a few things that affect the frequency that is played. All right, so here we've got a few general properties. F, which stands for frequency, will increase if the length of the string decreases. Okay, so the shorter the string is, the greater the frequency will be. And so when we look at a relationship, it's an inverse relationship where F is proportional to 1 over L. And just remember, inverse relationships mean that as one value goes up, the other value goes down. So in this case, as frequency increases, length will decrease. All right, frequency will increase if the tension increases in the string. So that's why you've got those tightening knobs on the end of a guitar and violin and other stringed instruments. The tighter you make that string, the more tension in that string, the higher the frequency is going to be. And it is a direct proportion, but it's not 1 to 1. It's the frequency is proportional to the square root of the tension. Now you do have to be careful here because tension is a T, temperature is a T, time is a T, and try not to get those mixed up. In this formula, frequency is proportional to the square root of the tension of the string. Again, as tension increases, frequency increases, but not 1 to 1. Okay, moving on. Frequency will also increase if the diameter decreases. Okay, so the thinner the string, the higher the frequency. All right, so again, that's an inverse proportion. Frequency is increasing as diameter is decreasing, and so here's our proportionality statement. F is proportional to 1 over D, 1 over the diameter. And again, now this D stands for diameter, not distance. And so again, we've got to be careful with that. When we're dealing with this unit, this D stands for diameter. Okay, moving on. Frequency will also increase if the density of the string decreases. Okay, there are various densities of strings. There are nylon strings, there are metal strings, different densities, and as the density decreases, the frequency will increase. And again, that's an inverse relationship, but again, it's not 1 to 1 like the other ones. This is F is proportional to 1 over the square root of P. P is the symbol for density. Okay, any one of you that have taken chemistry in the past, P is the symbol for density. All right, so what this does now is this gives us a few different formulas, a few different relationships, a few different ratios for things. So I got 4 ratios written on the bottom of the board here, okay? And these are the 4 that you're going to use for the questions that you'll get today and going forward when we have questions on vibrating strings. Okay, so here we've got two frequencies. Okay, so we're going to change the length of a string per se. Okay, and we're going to do an example on the other board in a minute. But we have frequency 1 over frequency 2 will equal L2 over L1. Okay, because it's an inverse, right? So we have frequency 1 in the numerator, but we have length 1 in the denominator on the other side of the relationship. Okay, so F1 over F2 is L2 over L1. Okay, moving into tension, F1 over F2, and they're all F1 over F2. Frequency 1, the original frequency, frequency 2, the frequency you want to move to, what has to happen. Okay, so frequency 1 over frequency 2, square root of the tension 1 over the square root of the tension 2. Now notice that it's frequency 1, tension 1, both in the numerator, because it's a direct proportion. Okay? Frequency 1 over frequency 2 is diameter 2 over diameter 1. Okay, again, inverse relationship, so the 1's, frequency 1, density 1, 1's in the numerator, 1's in the denominator. And same thing with density, frequency 1 over 2 equals square root of the density 2 over the square root of the density 1. Okay, inverse relationship. So 3 of the 4 are inverse relationships, F1 over F2, L2 over L1, while the 1, the tension 1, is a direct relationship, so we have F1 and T1 both in the numerator. All right, so these are the 4 formulas we're going to use. Let's go over to the other board. We'll do one example, and then I'm going to give you an assignment on a handout that will have 4 whole questions in it. So let's go to the board. All right, so here we go. Here's our example. So we have the D string on a violin, and it is 30 centimeters long. And it has a frequency of 288 hertz. So 288 hertz, if we play a note with 288 hertz, we are playing a D. All right, where must the violinist place his finger on the string to play a B? And a B is 384 hertz. Okay, and so we've all seen guitarists and violinists do this by moving their fingers up and down. They change the length of the string, and that changes the note they're playing. So where must this violinist place their finger so that they change the D string into a B? All right, so we'll write down our given information. We're told that the length is 30 centimeters. That's going to be L1. At L1, we get frequency 1, which is 288 hertz. Frequency 2 is the note we want to play, 384 hertz. And L2 is then what we are looking for. Our formula from the other board, F1 over F2 equals L2 over L1. Plug in our information, and we will get L2 equals to 22.5. So that means the string length has to be 22.5. So depending on which side you're coming from, your string length has to be 22.5. If you were moving your finger in from the end, you'd have to move your finger in 7.5 centimeters from the end of the violin. All right, that would then create a string length of 22.5 centimeters. I would accept either answer in terms of where you would have to place your fingers. 22.5 centimeters from one end, or 7.5 centimeters from the other end. All right, so again, the most important thing in questions like this is to write this information down. Right? Look at what you're given and what you need to find. And then we have 4 formulas which we will use, and one of those formulas will be the ones that we'll have to use, and it will give us the information we need. All right? So I'm going to give you 4 questions. It'll be on a handout. You'll find that on Connect. If you have questions, make sure you email me or phone me or ask me the questions in some way, somehow. And that's it for today. So we'll see you tomorrow.